Welcome to my lecture series on fluid mechanics 1 and another session which is composed of the numerical recipes or the numericals based on topics that we studied in the earlier lectures. So our first problem, calculate the intensity of pressure in kilonewton per centimeter square at a depth of 10 km in Pacific Ocean. Specific gravity of seawater is 1.02. So let us have a solution here. P by W is equal to H. Okay, H is equal to 10 km into 10 km. We have to convert in terms of meter into 1000. That is meter. So P by W, that is 1.02 into 10 into 1000. 10 km and multiplied by 1000. So it will be meter. 1.02 is specific gravity of Pacific Ocean and 9810 is the specific weight of water. So P is equal to 1.00 into 10 raised to 8 Newton per meter square. So that is equal to 1,62 kilonewton per meter square or 10.00 kilonewton per centimeter square. So this is the answer for this first problem. So let us take another example. Two pressure points in a water pipe are connected to a manometer which has the form of an inverted U-tube. The space above the water in the two limbs of the manometer is filled with toluene of specific gravity 0.875. If the difference of level of water columns in the two limbs is equal to 0.12 meter, what is the corresponding difference of pressure in Newton per meter square? So let us solve this problem. So let us have this setup. PA and PB, they are the other pressure points. Inverted U-tube manometer is connected between these two pressure points, and H dash, that is manometric level difference, is 0.12 meter, which is given in the problem. Specific gravity of toluene ST is given as 0.875 and water as 1, and H dash manometric level difference is 0.12. Now we will rewriting the equation. So PA by W going up minus Y, specific gravity of water up to this point is 1, so it is 1. Okay, then pressure at this particular point is equal to pressure at this particular point, that is C is equal to C dash. Then going down plus, here it is plus, okay, and again plus Y minus H dash into 1 minus PB by W is equal to 0. So PA by W minus PB by W equal to H dash 1 minus SF upon SW, that is ST or ST. So H dash is 0.12, 1 minus 0.875 upon 1, that is specific gravity of water is 1. So that is 0.12 into 0.125, that is equal to 0.015 meter. If you multiply by this, PA minus PB is equal to 0.015 into 9810, which is equal to 147.15 Newton per meter square. This is the right answer for this problem. We will take another problem here. A closed tank has a circular plan of 1 meter in diameter, contains 3 immiscible liquids as given in the following table. The space above has 60 mm of mercury vacuum. A pressure gauge which can read in kilonewton per meter square is attached in the tank at a height of 100 mm from the base. What will be the reading on the gauge? Okay, let us understand this table. Liquid A, B and C, their corresponding volumes are 0.314, 1.157 and 0.236, and their specific weights are 8000 Newton per meter cube, 12,000 Newton per meter cube and 9,000 Newton per meter cube. Okay, now we will solve the problem this. So let us consider the problem here. So 1 meter is the diameter of that cylinder. Heaviest liquid will lie at the bottom, then still heavier liquid will in the middle and the lighter liquid at the top. Then at the top there is a vacuum of 6 mm of mercury, and pressure gauge is connected here 10 cm above the base of the tank. Now let us find out the depth of liquid A. Depth of liquid A. So that is 0.314 upon pi 1 square upon 4. So volume is given here. So volume upon area, you will get the height. Similarly here also we find the height for B, and depth of liquid also we can find out as 3 meter. So 4 meter, 3 meter and 2 meter. These are the heights we have found out here. So this is the sketch here. 1 meter diameter, then 0.06 meter of mercury vacuum at the top, then A liquid which is lighter liquid, then C is the middle one and B is the heaviest liquid. So this way these are the three immiscible liquids. Then starting from top. So 0.06 millimeter of mercury multiplied by 13.6 is specific gravity into specific weight of water, plus height of first liquid, that is 4, depth of first liquid 4 into 8000, specific weight of that liquid is 8000, plus 3 into 9000 of specific weight of liquid C, and again we are coming down. So 0.10, so 2 minus 0.10, so that is plus 1.90 multiplied by specific weight of this liquid 12,000. Okay, which is equal to PA. So minus 8 plus 32 plus 27 plus 22.8 plus 22.8 kilonewton per meter square is equal to PA. So PA is equal to 73.8 kilonewton per meter square. This is the answer for this particular problem. So let us have visual once again. So this is 1 meter, lighter liquid at the top, 6 millimeter of mercury at the top, vacuum, then 8000 lighter liquid, 9000 middle specific gravity, and heaviest specific gravity at the bottom. So first of all we have found out the depth of liquid A, volume by area, because area we know pi d square upon 4, and volume it is given here. So corresponding depth we have found out here, 4 meter, 2 meter and 3 meter. Again, as you adopting the usual process from top to bottom, take positive sign. So minus 0.06, it is negative because it is vacuum, into 13.6 into 9810. So this is for the mercury. Then 4 into 8000, this is liquid A, 3 into 9000 liquid C, and 1.90 because it is 2 meter minus 0.10 because the dial gauge is above 0.10. So 1.90 into 12,000. So this will be PA. Then solve this. So we will get PA is equal to 73.8 kilonewton per meter square. This is our answer. If you like the contents of this lecture series, please give like and please do comment in the comment box, and please subscribe the channel if you are new to this particular channel, if you like it. Thank you. Please cooperate and do subscribe this channel.